Today we're going to talk about mathematical patterns and arithmetic sequences. A sequence is an ordered list of numbers. Each number in the list is called the term of the sequence. An infinite sequence is a sequence with an infinite number of terms. 3 dots or points of ellipses at the end of a sequence indicate that the pattern continues for an infinite number of terms. We also have our sequence notation. So use a variable such as a, or sometimes we use u, with a positive integer subscripts. And we've done this before. We've talked about this notation in Math 3. We also look at sequences in Math 1 and Math 2. So for our first term, the way that we would write that would be a sub 1. Second term would be a sub 2. Third term, a sub 3. So this term we call the previous term. A sub n minus 1. The nth term is a sub n, and the n plus 1 term is a sub n plus 1. So remember that you can only use positive integer subscripts when you're writing those. So let's go ahead and look at this. These two examples. It says, finding terms of a sequence, find the first 4 terms of each sequence. So if we want to find the first 4 terms, that means we're looking at first when n is equal to 1. So we're going to plug that into our formula. A sub 1 is equal to 3 times 1 minus 2. So you're just plugging in 1 for every where you have an n. And that gives us 3 minus 2, which is equal to 1. So that means that a sub 1 equals 1. Then if I want to find the second term, a sub 2, that means we're plugging in n equals 2 for all our n's in our equation. That gives us 3 times 2 minus 2. So 4 minus 2, 6 minus 2 is 4. So a sub 2 is equal to 4. And we can keep going. So a sub 3 equals 3 times 3 minus 2. So 9 minus 2, which gives us 7. A sub 4 is equal to 3 times 4 minus 2. So 12 minus 2, which gives us 10. And that gives us the first 4 terms, and we can keep going. So a sub 3 equals 7, and a sub 4 equals 10. And if we write this out, usually we use these braces, and then if you can't write that, if you just want to use a parentheses, that's fine. So 1 comma 4 comma 7 comma 10, and then dot dot dot, because that would continue on. That would be how we could write the terms of our sequence. So looking at the next one, we have a sub n equals 3 plus negative 1 to the power of n, which is not an arithmetic sequence. So for this one, again, you're plugging in the first 4 terms, so n equals 1 to n equals 4. So a sub 1 equals 3 plus negative 1 to the first power. So that would give us 2, and a sub 2 would be 3 plus negative 1 to the second power, which gives us 4. A sub 3 would be 3 plus negative 1 to the third power, which again gives us 2. And a sub 4 would be 3 plus negative 1 to the power of 4. Of course, even powers we know make the negative positive, which is why we're going back and forth between 2 and 4. So then we could write out the terms by just using our braces. So 2, 4, 2, 4, dot, dot, dot. And that would be our solution. So for the next part, we're going to look at recursive and explicit formulas, which we did in Math 1, 2, and 3. So specifically, we're going to look at arithmetic because we'll do geometric tomorrow. So in arithmetic, a recursive formula, we know, defines the terms in the sequence by relating each term to the ones before it. The formula consists of 2 parts. You always have to state both parts. The first part is where your sequence is going to start. Because if you have to use the previous term to get to the next term, you need to know what the first term is. and then an equation that tells us how that any term in the sequence is related to the term preceding it. So in this case, we have a sub n equals the previous term plus d, and d stands for the common difference. So a sub n stands for the nth term, a sub 1 is the first term, and n is the number of the term that we're on, and d is the common difference. So remember, we learned that to get to the nth term, you must know all the terms before it, which makes recursive a little bit harder than explicit for finding, like if you wanted to find the 100th term. So for the explicit form of the arithmetic sequence, sometimes you can find the value of a sequence without knowing the preceding term. Instead, you can use the number of the term to calculate its value. A formula that expresses the nth term in terms of n is an explicit formula. So here we have our arithmetic sequence with common difference. So, and this should just say a sub n because I changed it instead of using the variable u. So a sub n. A sub n equals a sub 1 plus n minus 1 times d for all n greater than or equal to 1. So a sub n is the nth term, a sub 1 is the first term, n is the number of the term that we're on, and of course d is the common difference. So for this next problem, it says, given the sequence, we want to write a recursive and an explicit formula. So the first thing I would do is figure out what my first term is and the common difference. So our first term, we can see from the sequence, would be that first number, which is 23. And we need our common difference. So to find the common difference, you are just going to subtract. So in this case, we can do any two terms together. So the term and the one preceding it, you're going to subtract. So 20 minus 23, of course, gives us a common difference of -3. So if I were to subtract -3 each time, you notice it gives me the next term. So for the recursive form, remember we have two parts. We have to state the first term, so a sub 1 equals 23, and then a formula for the nth term. So a sub n is equal to the previous term, a sub n minus 1, plus your common difference, which in this case is -3. So this would be my recursive form. Again, we're just using this formula here, your previous term plus your common difference. And then since we're in pre-calc, we're also going to state that for this one, n would have to be greater than or equal to 2. So for all n greater than or equal to 2. Why does n have to be greater than or equal to 2? Because we are starting with a first term. So if we didn't know that first term, watch what it would happen. If I were to plug 1 in and I didn't know 1, I would get a sub 1 minus 1 minus 3. So a sub 1 we know is equal to 23. But look what happens. I get a sub 1 minus 1, which is a sub 0 minus 3. So we don't have a 0 term. So that's why we wouldn't start with 1. That's why you have to start with n values greater than or equal to 2, because we're starting with the first term. So if I use 2, watch what happens. I get a sub 2 is equal to a sub 2 minus 1 minus 3. So that means the second term is equal to a sub 2 minus 1 is a sub 1 minus 3. So the second term is equal to the first term minus 3. And we know the first term is 23 minus 3, which gives us 20. And so that's just a good way to check. So that's why n is greater than or equal to 2. And for this, if I wanted to find the fifth term, notice that if I were to plug in 5 for n, I would get a sub 5 is equal to a sub 5 minus 1 minus 3. So a sub 5 equals the a sub 4, so the fourth term minus 3. And of course, I know the fourth term because this is an easy sequence. I have it right here, and I could easily subtract 3. But for more difficult ones, that's why recursive is harder, because you have to know the previous term in order to get to the next term. And if you don't know that previous term, you have to find all of those values up to it. So like if I wanted to find the 100th term, I have to find all 99 terms before it, which is why we don't always like to use the recursive form. I just wanted to point that out. All right, so I'm going to erase it so I have room for the explicit form. So again, the formula for this, remember, is a sub n equals the previous term plus the common difference for n values greater than or equal to 2. And of course, that's if you're starting with a first term of 1. You can start with 0, but often we just start with 1. So looking at then the explicit formula, so again, I'm just going to write down the formula. A sub n is equal to the first term plus n minus 1 times d for n values greater than or equal to 1. So in this case, a sub n is equal to, my first term we said was 23, plus n minus 1 times my common difference, which is negative 3. So I'm going to simplify this by distributing negative 3 to both these terms. So a sub n equals 23 minus 3n plus 3. So that gives me a sub n equals negative 3n plus 26. And that's for n values greater than or equal to 1. And so why do n values have to be greater than or equal to 1? Because we're using a first term over here. If we were using a 0 term, then it would be n greater than or equal to 0. So just kind of keep that in mind. It does change based upon whatever your first term that is you're using, but most of the time, like I said, you're going to use your first term as 1, so n equals 1. All right, looking at the next, and before we move on, we also like the explicit form because if I wanted to find the 100th term, all I would have to do is plug 100 in for n, and then I could easily find it by combining my like terms, unlike the recursive. So arithmetic sequence. An arithmetic sequence or arithmetic progression, same thing, is a sequence of numbers in which the difference between each term and the preceding term is always constant. This constant is called the common difference. You can find the common difference by subtracting any two consecutive terms, which we just looked at. So if we want to look at these A, B, and C right here, we want to figure out, are they arithmetic? If so, what's the difference between each term and the term preceding it? So looking at this first one, you have to look at each term. If you were to subtract each of the terms, 10 minus 14, 6 minus 10, 2 minus 6, etc., you would get a common difference of negative 4. So yes, this is arithmetic, and the common difference is negative 4. So looking at the next one, same thing. If we subtract 6 minus 2, 10 minus 6, 14 minus 10, 18 minus 14, we get the common difference is 4. So yes, common difference equals 4. And for the last one, if we subtract 5 minus 3, 8 minus 5, you'll notice that you're not going to get the same 12 minus 8, 17 minus 12, you're not going to get the same common difference, so this is not arithmetic. Next example says, find the nth term of the arithmetic sequence with the first term of negative 5 and the common difference of 3. So a sub 1 equals 5 and the common difference is equal to 3. So if I want to find, we're going to find both the explicit and recursive. So if I want to find the explicit form, we know that explicit, we're using a sub n is equal to a sub 1 plus n minus 1 times the common difference. So we're just plugging into that formula. So a sub n is equal to 5 plus n minus 1 times 3. And then I'm going to distribute that 3 here. So a sub n is equal to 5 plus 3n minus 3. And sorry, this is negative 5, so negative 5 here. So then combine our like terms, negative 5, negative 3 gives us negative 8. So our explicit form would be a sub n equals 3n minus 8 for all n values greater than or equal to 1. So that is my explicit form. Now I want my recursive form. So remember, for the recursive, you have to state the first term, a sub 1 equals -5, and then the formula is a sub n equals the previous term plus the common difference. So a sub n equals a sub n minus 1, and then plus 3. So now we have our explicit form and our recursive form. So if I wanted to find the actual sequence, and in terms of the sequence, I could use either formula. So I know the first term is -5. It'd probably be easier just to use the fact that we know the common difference is 3. So basically we are adding 3 each time. So -5, -2, 1, 4, 7, and etc. So that would be the actual sequence if we were to write it out. All right. For the next example, it says, what is the 45th term of the arithmetic sequence whose first 3 terms are 5, 9, and 13? So first we want to find our first term, which we know is already there, which is 5. Then we want to find the common difference. So the common difference we find by subtracting the consecutive terms. 9 minus 5 is equal to 4. So that is our common difference. And of course, we would want to use the recursive formula to find the 45th term, but I'm going to go ahead and practice both. So here we have the recursive, our explicit form. So we're going to do recursive first. So recursive, state the first term, and the nth term is equal to the previous term, and plus the common difference for n values greater than or equal to 1. Which reminds me, I need to go back up here because I forgot to state that for the recursive form, n is greater than or equal to 2. And so, oops, I wrote 1 here, sorry, 2 for this one because it takes the previous term. So now we have our recursive form, so then the explicit form, we have a sub n equals our first term, which is 5, plus n minus 1 times our common difference, which is 4. Going to simplify this, so we get 5 plus 4n minus 4. So that gives us a sub n equals 4n plus 1 for n values greater than or equal to 1. So that would be my explicit form. And so if I want to find the 45th term, like I said, you don't want to use the recursive form because that means you would have to find all the terms up to the 45th term. So the explicit one is going to be the one that's easier. So a sub 45 means we can just plug it in for n into our equation and solve. So 4 times 45 plus 1 is going to give us our answer. So the 45th term is equal to 181. All right, for the next one, it says u sub n is an arithmetic sequence with u sub 6 equals 57, u sub 10 equals 93. Find the first term and write the recursive and explicit form for the nth term. So in this case, to find our first term, we need to know what our common difference is, right? So to find the common difference, you can subtract consecutive terms, except for we don't have the terms right next to each other, right? We have the 6th term and the 10th term. So we could subtract those terms, 93 minus 57, and the difference between them, which would be 10 minus 6. So if we do that, we end up with our common difference of 9. And so since it told us this is an arithmetic sequence, we can take 57 and subtract 9 from it 5 times, which is, of course, subtracting 45. So if we do that, we end up with 12. So our first term, so u sub 1, I'm using u instead of a like the last ones because it says u sub n here. So u sub 1 is equal to 12. So now we can write our recursive. So the recursive form, I have to state my first term. So a sub, sorry, you should be using u. So u sub 1 equals 12, and u sub n is equal to the previous term, u sub n minus 1, and then plus my common difference, which is 9, for n values greater than or equal to 2. And then for my explicit form, we have u sub n is equal to my first term, which is 12, plus n minus 1 times my common difference, which is 9. And then I'm going to distribute. So we get 12 plus 9n minus 9. So u sub n is equal to 9n plus 3 for n values greater than or equal to 1. All right, so this next example is pretty much the same as the one we just did. So you do this one on your own, and if you need to, you can check your work with the online answer key. All right, so for the next one, it says, suppose you participate in a bike-a-thon for charity. The charity starts with $1,100 in donations. Each participant must raise at least $35 in pledges. What is the minimum amount of money raised if there are 75 participants? So for this one here, if we start off with our first term, we can say that we're starting off with the amount for the donations, so 1,100. And our common difference, of course, would be 35. So then for the explicit form, we're going to use that one to help us solve this. We have a sub n equals 1,100 plus n minus 1 times 35. And if we simplify this, we would get a sub n equals 35n plus, and then it would be 1,100 minus 35, which is 1,065 for n values greater than or equal to 1. So that's my equation. So if we want to figure out the, if there's 75 participants, the minimum amount of money raised, then remember that your first term is not a participant. So you need to add 175 plus that 1. So that means that you're going to be adding, instead you're going to find n equals 76, because again, since the number of donations is 1,100, that doesn't count as a person. So 75 is the number of participants plus that 1, which gives us 76. So a sub 76 is equal to 35 times 76 plus 1,065. So that gives us, when we solve it, $3,725 would be the minimum amount of money raised if there were 75 participants. Now, I also want to point out too that technically it's not the only equation we can actually find, because we could start off with a starting amount of a sub 0 equal 1,100 and our common difference being 35, which would keep in mind, think about y equals mx plus b slope-intercept form. So we could also say a sub n equals 35 n plus the 1,100. And if we did this with a 0 term, then you could use a sub 75 in your equation. And if you did that, you would end up with the same answer. The difference being that you have to be careful with your equation. since we're starting with a zero term, it changes what the actual equation looks like. That this means this would be your starting amount and this would be your slope of your equation. So that would be another equation that you technically could write if you wanted to start off with a zero term. But since we're using that formula with your first term plus n minus 1 times d, that always uses a first term. So I just wanted to point that out. So another thing to look at is the arithmetic mean. So the arithmetic mean of any two numbers is the average of the two numbers divided by 2. So if we wanted to find, it says for any 3 sequential terms in an arithmetic sequence, the middle term is the arithmetic mean of the first and the third terms. So if we wanted to find that, then we could do negative 16 plus 1 divided by 2, which gives me negative 7.5. So that would be the missing term. And if you think about your graphs for arithmetic graphs, they're always going to be linear since it is considered with a common difference, which would be, again, like I said, your slope of your equation. And that is all for our arithmetic sequences. And like I said, we'll be looking at geometric next.